This is the screencast for section 3.2, example 6, determining altitude from atmospheric pressure. Scientists have established that atmospheric pressure at sea level is 14.7 pounds per square inch. So for every square inch of water, it feels like 14.7 pounds are pressing down on that square inch. And the pressure is reduced by half for each 3.6 miles above sea level. So reduced by half is very similar to half-life. And then for each 3.6 miles is kind of like for every 5 days or for every 20 days, etc. So we're supposed to find the altitude above sea level at which the atmospheric pressure is 4 pounds per square inch. So we've decayed down to 4 pounds from 14.7. So to set up that to set up the exponential decay equation, the initial pressure was 14.7 pounds per square inch. The pressure is cut in half, so it's not officially a half-life because we're not talking about radioactive decay, but it's very similar to half-life. Half of it will be left for every 3.6 miles. So not every mile, but 3.6 miles. So I'm actually going to make this P of M, where M equals miles. I'm looking for an atmospheric pressure of 4 pounds per square inch. Again, I don't know how to solve for exponents, so I'm going to let my calculator help me solve this. For my window, if half of the pressure is lost every 3.6 miles, I figure, okay, how many halves do I need to lose to get from 14.7 down to 4? So about 4 miles will drop me down to about 7. Another 4 miles will drop me down to a 3.5. So I figured it would be about 8, but just to play it safe, I put my X max down to 20. Or out to 20 miles. We'll see what happens. It could be too big, but I think I'm just playing it safe at this point. And then for my Y max, my initial pressure was 14.7, so I just set my Y max to 20. Now I can see the intersection pretty clearly. I definitely could have cut off my X max a little bit, but this is still fine. So I'm going to find my intersection, and it's about 6.76 miles up. I will feel a atmospheric pressure of 4 pounds per square inch. Number 41 is also it was an algebra problem also dealing with atmospheric pressure. Determine the atmospheric pressure outside an aircraft flying at 52,800 feet, 10 miles above sea level. So we can use this same formula because the atmospheric pressure doesn't change per situation. Atmospheric pressure is constant, well, actually exponential, throughout the planet. So if we have a plane flying at 10 miles above sea level, I'm going to determine, so now I know the M value. So I'm going to find P of 10. Well, if it takes 3.6 miles to cut that in half, let's see, we've got about 3 sets of cutting in half. So cutting in half would be 7, about half of that would be 3.5, half of that would be like 1.75. So I'm thinking it's going to be a little under 2. So let's see what the calculator comes up with. 14.7, my initial pressure, times, I lose half of it every 3.6 miles, but I'm going to do 10 miles. So I got a little over 2. That's what happens when you approximate in your head. So in this case, P of 10 equaled 2.14 pounds per square inch.